everyone, for having me today. My topic today is a keynote that I've been doing called Metamodern Software Architecture. And this really comes from the book that I wrote a couple of books ago called Fundamentals of Software Architecture. And one of the things that Mark and I are trying to do in that book is really try to define kind of the fundamentals, what does the role look like, et cetera. And one of the things that we talk about, in fact, the entire second part of the book are all these architecture styles, these named topologies in software architecture. And I got to wondering at some point about where do these things come from? How do these things come about? It's not that software architects go to some ivory tower somewhere and think, what is the next thing we're going to do in software architecture? Instead, what happens is, in the software development world, it's constantly shifting and evolving. As he mentioned, I wrote the book, Building Evolutionary Architectures. Our whole ecosystem is constantly shifting and changing, and what happens is some new capability shows up somewhere, and some clever architect looks at that and says, I could take one of those and three of those and combine it with one of these and solve this problem we've had forever, so I'm going to start doing that. And then other software architects look and say, hey, that's really clever what they did over there with the two things and the one thing and put it together like that, so we should do that too. And before long, so many people have done that people say, we should name that thing because it takes too long to say these two things plus that thing, so we'll name it microservices. Okay, that's what we'll call that thing from now on. And now our ecosystem has changed a little bit because we've come up with these new ways of thinking about things. And I was struck as I was looking at that process because it's a reflective process. It happens after the fact because we don't predict these styles. These styles are a reflection of things that happen in our ecosystem, and we name them after the fact. And I was struck because there's another phenomenon that happens exactly the same way, and it's these cultural eras that exist. So let me spend a couple of minutes talking about this. And the first one I want to talk about is Victorianism, which is 1800 to about 1901. Victorianism, the political agenda was increasingly liberal, political reform and industrial revolution. So this is when the Industrial Revolution happened. People moved into cities, and science was a big deal here. And in fact, they really wanted to classify the natural world. This is post-photography, so art became not representative, became something that was interpretive rather than representative. That's when the Expressionists came about, was in Victorian times. After Victorianism was an era that was called Modernism. And before you complain about the names of these things, you think naming things in software is hard, try naming cultural phenomenon, because obviously if you name something modern, what are you going to name the next thing? But I didn't come up with these. I'm just reporting what exists in the world. So modernism existed from about 1890 to exactly 1945. And modernism is a reaction to the Industrial Revolution that led into Victorianism, which led to the explosive growth of cities, and it changed people's perspectives on things. We went from a very rural lifestyle to a very urban lifestyle, and there was a big reaction to that in the arts. This is when the absurd art like Brecht came out, and Waiting for Godot, and a lot of these very incomprehensible art things that made no sense, that have no plots. This is when one of my favorite art movements came along, the abstract expressionists with Pollock. And even Pollock, when he did all the drips, people would look at these paintings and go, well, I see a dog and a horse and a cloud. And he said, no dog, no horse, no cloud. It's supposed to be as abstract as possible, which leads to my actual favorite artist of this time, Mark Rothko, because his paintings were so abstract that you can't see a horse or a dog or a cloud. All you can see are rectangles floating in space. And this was part of abstract expressionism. This, of course, was the era of radio as well, and this dominated the way that we consumed information in the modern era. After modernism came Believe it or not, postmodernism, which now immediately begs the question, well, okay, what's going to come after that? But we'll get to that in a second. So postmodernism was from 1945 to about 1990, and it was an exact reaction to modernism. These were novelists like William Burroughs, the Beat writers, Kurt Vonnegut, but a lot of skepticism and in particular irony. A lot of the art in this era had a lot of ironic feel to it. This were, as I mentioned, the Beat writers like Jack Kerouac and William Burroughs in the 50s Beat movement. This is when actors became method actors and really got into acting, James Dean and Marlon Brando. But the dominant cultural force in this era, of course, was TV. TV came about, changed the way people consumed information again. In fact, if you read books from the 1890s of Victorianism, they are very slow on purpose because there was no radio or TV. It was meant to be long and slow and entertaining. And of course, TV shortens all that and changes the way we consume stuff. But the really overwhelming kind of cultural feel of postmodernism was irony. And you can see this in a lot of the movies and TV shows from this era. Seinfeld is a great example of this, if you've seen the Seinfeld TV show, because the mantra of Seinfeld is no hugging and no learning. We never learn lessons and we never hug. We never learn anything. Everything is as ironic as it can be. So after postmodernism, what comes next? Because we're living in the one that comes next. And the most common name for this, some people call this, and I'm not kidding, postmodernism, which again, is going to create some real problems after this one. But the more common name for this is metamodernism. And this has nothing to do with metaprogramming or Meta, the corporation. I refuse to allow them to steal the concept of Meta as their name. But metamodernism is interesting in a way that the others are not as much because, well, David Foster Wallace, who's one of the greatest American authors of the 20th century, is the one that coined many of the principles of metamodernism just before 1990. He wrote a fantastic book called, is a nonfiction essays called A Supposedly Fun Thing I'll Never Do Again, which is about his experience on a cruise ship. But he also wrote a fascinating thing, which is a review of a dictionary that's one of the most fascinating things you'll ever read. He was that good a writer that he could write a review of a dictionary that was quite compelling. And he wrote one of the best books of the 20th century, Infinite Jest. And one of the things that he predicted in this move from postmodernism to modernism was the return of genuine sentimentality. And we'll talk about that in just a second. But what really pushed us from postmodernism into metamodernism? And it was, again, this change in the way that cultural communication happens. And of course, the change that was enacted during that time period was the arrival of the internet. And here are a couple of examples of this. So in the postmodern era, so let's say it's 1990, just pre-internet, let's say that I want to travel from my home in Atlanta to Vienna, Austria. And I need to know what kind of clothes to bring to Vienna, so I need to know what the weather's going to be next week in Vienna. How would I figure that out? Well, I could go to a TV channel like the Weather Channel, and they will occasionally do other countries' weather, and so I could wait until it cycles around to see what the weather might be. Or if I knew somebody here, I could call them and say, hey, would you look in your newspaper and see what it's going to be next week? Or maybe you can go to a library, and maybe they would have a local newspaper. But, I'd probably just guess and not try to research it because it's way too much trouble to figure that out. I can now tell you what the weather is going to be like anywhere in the world in 10 seconds or less. Because I have the internet, I have mobile devices, I have this kind of connectivity. And it's not just that it made things easy, it made things that were impossible before completely trivially easy. Another example, let's say in the postmodern world, I wanted to write an article about wine. Where would I find out information? Well, I could go to magazines, I could go to newspaper articles, I could go to books about wine, and by the time I was finished, or maybe even videotapes about wine, by the time I'm finished, I've probably covered some reasonable percentage of all the things that we know about wine in the world. But today, there's no way because they're adding more stuff about wine to the internet faster than I could possibly ever consume that. And so everything about our information has completely changed. And one of the things this change has driven, and one of the defining characteristics of metamodernism, is this idea of holism. That we can't look at narrow things anymore. We have to consider broader perspectives, because I can't ever know everything there is to know about wine. There's just too much coming all the time, and I have to take a broader perspective on this. And a lot of the entertainment that we're starting to see embraces some of this. If you've seen some shows like Parks and Recreation, it's a good example. There's a great article on about what is metamodernism by this writer named Seth Abramson. If you've ever seen the show Breaking Bad, it's an interesting combination of things because it's an interesting story, but if you don't know this, this will change your whole perspective about Breaking Bad, because there's a whole bunch of color symbology layered into the Breaking Bad universe as well. And if you'll notice in the Breaking Bad world, things that are yellow and khaki are safe, wholesome, and unbroken good things, and everything that's purple is unsafe, drug-related, and Breaking Bad. You can watch the entire series and predict what characters are going to do depending on what color clothes they're wearing. There's literally a scene where one character takes off a yellow shirt and puts on a purple shirt because they're about to go do some evil somewhere. And so it gives this extra dimension to all the things that are happening there. If you're familiar with this show Ted Lasso on Apple TV, one of the things that David Foster Wallace predicted is a departure from irony and a return to what he called genuine sentimentality. And that's exactly what this show does. It just drips with sentimentality. If you've seen this year's best movie Oscar winner, Everything, Everywhere, All at Once, this is a great example. And in fact, there was an article in the New York Times just this last week about movies are different now, because there is no single genre that describes this movie. Movies in the modern and postmodern era were in a genre. They were action or romance or science fiction. This one is a science fiction fantasy thing that's a family drama, and it's a kind of a mother-daughter thing. Oh, and it's a comedy, and it's everything. And movies increasingly now are undefinable from a genre because of this holistic effect that metamodernism is having on us. But let's talk about how this holism idea affects us in the software world and go back to software architecture and this idea of classification. I said before that this classification happens after the fact, but that's not entirely true, because when microservices came along, we've gotten meta about this process of new architecture styles coming along. And relatively early in the appearance of microservices, Martin Fowler and James Lewis wrote on Martin Fowler's blog, this blog that kind of defined what it is and most importantly what it isn't. And I think that helped us get away from because normally when these things come out, in fact, you've seen this Gartner adoption curve where there's this hype cycle and then it goes into this trough of disillusionment and it finally evens out into this plateau of usability. I think this prevented microservices from being wildly misused because it kind of defined what they are and aren't, and it helped a bit in this process of helping us understand how to build things. And in fact, I would say that microservices haven't hit the trough of disillusionment yet because we're still very successful with them. But it's also a great example of what we codified as our first law of software architecture, that everything in software architecture is a trade-off. And if you think you've found something that isn't a trade-off, it just means you haven't discovered what that trade-off is yet. And this is a very holistic view of problems in software. And let me give you a great example of this. Reuse. Code reuse is awesome, right? This is a force for good in most organizations. In fact, I have a lot of companies tell me, we really want to build a really nicely, highly decoupled architecture like microservices, and we would like to achieve a high degree of reuse in our code. And I have to explain to them, well, reuse is coupling. That's how you reuse things, is couple them together. So you cannot have decoupled and reuse at the same time. But let's talk about a very postmodern view of reuse in software architecture. In fact, architects were instructed to look for this pattern quite often. Let's say you're a big insurance company with all these divisions, and at some point you notice, hey, look, they all have some flavor of customer in them. Therefore, what I should do is consolidate all those into a single customer service and just let all the parts of my organization talk to that single customer service. I've achieved awesome code reuse. Now everything we know about customer is in one place. Good that you've achieved reuse. What you fail to do is evaluate the trade-offs, because everything in software architecture is a trade-off. So there are two problems with this that we discovered, and one of them you can kind of work around, and the other is absolutely deadly. The first one is complexity. If you put everything you know about customer into one place, that thing is going to be really complicated. And if one of these insurance divisions needs to deal with that thing, it's got to deal with all the details of all the divisions of insurance, and so it's really big and complicated. But you know, you can kind of fight your way through that if you want. But the thing that's deadly here is you have created a gigantic high coupling mess. Because if you build an entire architecture over as much reuse as possible, you have created a brittle architecture. Because every time I change that customer service, everything that's coupled to it has to stop and coordinate around that change. Even if they don't have to change, they still have to test to see if that change is going to affect them. And this slows everything down to a crawl in organizations that are trying to maximize reuse like this. This is one of the reasons you don't do this in microservices. And in fact, the idea from domain-driven design in microservices is that very often duplication is preferable to coupling. Because, and this is really important, both of them suck. And the question for you as an architect is which one sucks less? That is always the thing you're looking for as an architect. In fact, Mark and I don't talk about best design in architecture because that assumes that you've maximized every single thing. We talk about the least worst design in architecture. What's the least worst combination of these trade-offs that you can deal with? But what's a more meta-modern, holistic view of reuse? And what does a meta-modern software architect, or more importantly, an architect think about in this world? I firmly believe that the role of architect is not to find silver bullets laying around, because they just don't exist. Your best job as a software architect is to become the really good evaluator of trade-offs. When a decision maker needs to make an important decision, they should come to you because they know you will give them the good and the bad in as objective a way as possible. You're not good as an evangelist. You should be the objective arbiter of trade-offs. And here's a good example of that for the reuse example I had before. Reuse is interesting because everybody gets the first part right, but then they miss the second part. And the first part is abstraction. Oh, look, we could use this from multiple places, so we should abstract that and reuse it. But the thing that actually makes it useful is slow rate of change. That's the thing that makes reuse actually reusable. And notice what we successfully reuse in software systems. Frameworks, libraries, containers, it's all the plumbing stuff. What things change the fastest in your software? It's your domain. It's the things that you're writing software about change the fastest. Therefore, they make the worst candidates for reuse. This is exactly why microservices say prefer duplication over coupling for domain concepts, because the more you couple those things together, the more you slow things down, because everything that's coupled, you have to slow down around that coupling point. This is exactly the bounded context idea in domain-driven design. Don't share entities across bounded context. Let them have their own entity so that you decrease coupling, because those things change the fastest. Here's another example of a kind of holistic view of a software architecture. Some of you may be familiar with this pattern called a hexagonal architecture that Alistair Cockburn came up with back in the early days of distributed computing in the early 1990s. And this is a really clever idea because basically what he said was, well, we should really separate the business logic in our application from all the plumbing, the REST and command adapters and event adapters and databases, et cetera. He called this a hexagonal architecture because when he first had this idea, he drew a hexagon and thought it looked cool, so that's where the name came from. He eventually called this a ports and adapters architecture, which is actually more descriptive, but this is why you see so many hexagons in microservice books, because it looks cool. And he almost got this right. Almost got it right. But he missed one really important thing in the early 90s. That this is not a separate thing, even though it's a separate mechanism, it's part of the business logic. You can't separate that because if you change your schema, you're going to change your code and vice versa. And that's the insight that Eric Evans had a decade later in domain-driven design, that yes, in fact, the database and its schema is part of your bounded context and should be inside that service boundary. But part of the goal of hexagonal architecture was separate the plumbing from the domain stuff, because what about the things in our architecture that we really benefit from coupling together? Monitoring, logging, authentication, authorization, service discovery, circuit breakers. Those are all things that are not part of my domain. And in fact, I really want uniform access. I want the same monitoring tool for every service. I don't want each team picking their own monitoring tool because I can't use that as a large corporation. That's where this idea of a sidecar comes from. It doesn't take long building microservices before you realize they all have these same kind of operational concerns. So let's build a sidecar component that includes all the plumbing stuff in it. If you can assume that every one of your microservices has this common component in it, then you can build a service pane that actually allows them to communicate with each other. And this is the idea in microservices of a service mesh. It allows you to couple the operational parts of your architecture together without coupling the domain parts together. And this is exactly what you want. It's the kind of coupling you want, kind of overlaid on your domain, a very loosely coupled architecture. But you can take this idea one step further, and a great example of that, which is this relatively new thing out in the world, is this idea of a data mesh and managing analytical data. So one of the things that we have struggled with for a long time in software architecture is this split between operational and analytical data. Operational data is things like sales, transactions, catalog items, inventory, the things that we run our business on. But analytical data are things like business forecasting and machine learning, business intelligence. And very often it uses the same source data, but in completely different formats and different ways. And we've tried a bunch of ways to manage this in the past, but have not been super successful. Data warehouses were big and expensive, and they didn't really give us the stuff they wanted. Then the pendulum swung to this idea of data lakes. Just take the unformed data and throw it into a big lake, and we'll fish it out as we need it. But then those quickly become data swamps, and then eventually data sewers, and then it's all a whole bunch of stuff that nobody understands what they are. The most modern approach to this, and I dare say meta-modern approach to this, is this idea of a data mesh. And it borrows some of the ideas from the idea of a service mesh in microservices. But the difference here is you can't have a component inside my microservice that manages analytical stuff, because it would have to query the database, and that would kind of ruin the operational aspects of my service. And so the idea in a data mesh is you have a cooperative service called a data product that sits alongside your regular microservice, and it's purely responsible for the analytics part of your application. It has a database, but it may be a different kind of database, because it may be holding rolled up snapshots of data or tabular data or aggregations or something like that, that the analytics part of your ecosystem talks to. And so you have services, which the operational part of your architecture talks to, and you have these data products, which the analytics part of your architecture to, and they are loosely coupled to one another by this communication between the data product and this service, so that as it gathers more operational data, this can gather it and aggregate it, et cetera, to do interesting things with it. And so you're basically now building two architectures that are parallel to each other, that are coupled together in a very specific way just around the kind of operational analytical data. So each one of your services has this data product that's aligned and associated with it. So for example, you might have in a ticket management system, you may have ticket maintenance as assignment. Those both feed assigned and completed tickets into a data product that gives you both a file snapshot or tabular snapshot. We have an example in our hard parts book of this. Basically, what we have in the U.S. is this thing called the Geek Squad that drives around and experts that work on your computer and your TV, et cetera. So if you had an ecosystem like that, maybe you would have an expert service and a ticketing data service and a survey service. Each of those would have a data product associated with it. And then you have an expert service part of your analytics architecture that pulls in data, because I need what my experts currently know, what kind of tickets am I servicing, and what kind of surveys are my users answering. Those together, plus information pulled in from the outside world, from what skills exist out in the world, that will feed into the analytics part of my architecture to allow me to do machine learning to predict what kind of expert should I hire next year. Because if I hire a bunch of TV experts and people are buying game consoles, then my business model doesn't work. And so this is a great example of deriving analytical data into, or deriving operational data into analytical data and using that in almost this kind of parallel architecture. It's a really clever idea because it shows a way of building distributed architectures that are coupled in a very specific way to each other, almost overlaid on top of one another. And we talk about this a little bit in our hard parts book, but Zhamak, who created this idea, has written an entire book about it called Data Mesh. This is what happens when you take an expert on distributed architecture and plunk her down in front of a difficult analytics problem and say, hey, do you think you can solve this? And it turns out she can. So let's look at another example of this holistic approach from a software architecture standpoint. And this is one of the things that we kind of ran across in our software architecture, the hard parts book. When you think about workflows like this in a microservice architecture, as we were writing our hard parts book, we wanted to say some interesting stuff about this kind of workflow and transactional workflows like this. And we were struggling because we kept bumping into, we build all these samples, but then we noticed an interesting phenomenon that every time you changed one small thing, it shuffled everything. It was almost like fractals have this sensitivity to initial conditions. One small change causes a massive change in the output of what you're looking at. And what we eventually figured out was that we were dealing with what we call three primal forces. One of these was consistency. Is this workflow trying to achieve atomicity at the workflow level, or is it eventually consistent of some kind? The second primal force was communication. Is it synchronous or asynchronous communication? And the third one of these was coordination. Is it using orchestration or is it using choreography? And as we were playing with these things, we realized the reason that you can't change one of these without affecting all the others is that these things are actually in a three-dimensional conjoined space. That when you make decisions in this space, you're putting a dot in this three-dimensional space, and as you try to move it around, there's gravity. It's harder to move to some edges of this thing than others because it drives complexity up, or it drives coupling up, or some other characteristic of software architecture. And so Mark and I looked at this and decided, well, you know, there are three primal forces, and they each have two possibilities on either edge of their spectra. So why don't we just model all of them? There are 8 possible combinations, and so that's exactly what we did. And we gave them all a whimsical name because these are all sagas. A saga is a transactional workflow, so we gave them all sort of whimsical names of what kind of saga it is. This, for example, is an epic saga with synchronous, atomic, and orchestrated coordination versus a fairy tale saga, which is synchronous and eventual consistency and orchestrated, versus a time travel saga, which is synchronous, eventual consistency, and choreography. And notice the dots moving to a different space. There's the phone tag saga, the parallel saga, fantasy fiction. The worst one of these is one that's called a horror story, because this is the one that is definitely an anti-pattern. You don't want to stumble into this. And what happens when you go through all of these is you start developing a feel for what really does drive up coupling and scalability. If I really wanted a scalable solution, what things should I try to use for that? And what it allows you to do by going through this entire analysis, this is what we refer to as qualitative analysis of these different architecture styles. It allows you to create a scorecard like this. We scored each of these with 2 green dots being the best score, 2 red dots being the worst score, and some in between. And what this allows you to do is think about things in a more holistic way. Because one of the pieces of advice you get that's terrible is that, oh, you shouldn't use orchestration in microservices because it causes all kinds of problems. And sure enough, there's orchestration and a whole lot of red dots, which doesn't look good. But then you look over here and you see orchestration, but a number of green dots there. It turns out it's not orchestration by itself. It's the combination of orchestration and that atomic scope that's driving up all this complexity. And what this allows you to do is start making some value judgments. Okay, I need an architecture that's really, really scalable. Okay, well, there's scalability, so looks like this is a good one, but it's using choreography and I have kind of a complex workflow, so I would benefit more from having an orchestrator to manage that. So are there any green ones that do orchestration? Yep, sure enough, and there's the parallel saga. This allows me to limit the options I have and qualitatively pick which one I'm interested in. That's an example of this holistic view of all the forces, not these narrow views of should I choose synchronous versus asynchronous. You have to think about all those things together, which is a good example of holism. What I didn't talk about was the shift into modernism. You'll notice there was a hard barrier there in 1945. Let's talk for a second about pre-1945 and physicists. Physicists pre-1945 had this kind of wacky persona. This is Einstein, of course, with his mismatched socks and his crazy hair. This is a fascinating figure. If you don't know Richard Feynman, he was one of the, worked at Los Alamos. He also created quantum physics. There's an interesting phenomenon about Richard Feynman. You may be familiar with this idea, 6 degrees of separation. This is actually a postmodern play, but what it supposed was that every person on Earth is 6 degrees of separation from every other person on Earth. And sure enough, it turns out I am 3 degrees of separation from Richard Feynman, the physicist, because one of my colleagues in Australia has a son that worked with Feynman's son, which means I'm 4 links away from Albert Einstein, because Feynman knew Albert Einstein. So the 6 degrees of separation thing really is pretty true. Feynman was interesting because he was a very innovative. He actually created some patents for parallel computing before computers existed. If you look up computer pre-1945, it is a person who does computations. And during World War II, they had rooms full of women with adding machines and slide rules doing artillery trajectories. He figured out how to make them run in parallel. And so he created some patents for parallel computing before computers existed. He also has patents in biology and a bunch of other stuff. He also created quantum mechanics, one of the creators of quantum mechanics. He was also really, really eccentric. And somebody said it's really good that he won the Nobel Prize early in his career, because if you act the way he does with a Nobel Prize, you're eccentric. If you act the way he does without a Nobel Prize, you're just a crazy person. Here's a good example. This is Richard Feynman playing the bongos, singing about orange juice. This is Nobel Prize winning physicist Richard Feynman, one of his hobbies, which is playing bongo drums, singing about issues. So what moved us from the modern to the postmodern era? It was, of course, the thing that happened in 1945, the atomic bomb. And Richard Feynman is the only person that actually witnessed the first atomic bomb explosion, because when they blew up the first test bomb, they were way far away in a bunker, and Feynman understood the radiation and all that stuff, and everybody else was wearing goggles, and he actually stuck his head up and watched the flare in the distance and then ducked his head because he knew that was probably safe to do so. He was the only physical eyewitness of this thing. But he's also a really important cautionary tale, because in his later life, what he said was, when he was talking about the atomic bomb project, was, with any project like that, you continue to work trying to get success, having decided to do it, because they got caught up in the problem-solving part of getting the bomb to work. And he said, but what I did immorally, I would say, was to not remember the reason I said I was doing it, so that when the reason changed, not the singlest thought came to my mind that meant that now I have to reconsider why I'm continuing to do this. His point was, after the war in Europe ended, they should have stopped working on the atomic bomb, but they were caught up in the problem-solving physics of it. Can we actually get this thing to work? And then they did, and they regretted it for the rest of their lives. Robert Oppenheimer, who ran that project, was also affected. In fact, he spent the rest of his life trying to create groups that would try to limit the spread of nuclear power and nuclear proliferation. Before the current era, when you look at programmers and scientists, before the atomic bomb, they were mostly considered kind of harmless, but that's when the evil scientist persona moved into our culture, and we started thinking of scientists as dangerous people. So let's talk about the thing that moved us from the postmodern to the metamodern, and of course it is the internet and this idea of holism. Mostly now we think of developers as kind of harmless people. We had some Simpsons references up here earlier, and these kind of geeky photos. But increasingly, this public persona is changing because of the Volkswagen scandal. Volkswagen purposely built the software in their cars to cheat on emissions tests. And while that's bad enough, you and I all know enough about software to know that at least some people there had to know that there was a special switch in the software that said, when you're being tested, give one number versus the actual number. Somebody had to design that into that piece of software, which brings up, of course, Facebook. Facebook is an interesting corporation because they just won't stop doing bad stuff. They keep getting busted over and over and over and over again, and they just won't quit doing stuff. They were recently fined 1.3 billion euros by the European Union because of another data breach that they claim that they didn't do, using two-factor authentication, emails for marketing, cheating on when the Apple brought out the new system that said you don't have to be tracked anymore. They actually just hacked that and went around it behind the operating system. We suspected this for a long time, but then whistleblowers came out and let us know about this. And of course, they're doing a lot of, so if anybody understands how internet memes should work, it should be Facebook. But there was a rumor that got started that on Facebook, it was called the Slap Your Teacher TikTok Challenge, which did not exist before Facebook put it into the ether. But guess what happened as soon as Facebook started talking about that? It became a real thing, because that's the way internet memes work. One of the former presidents of Facebook said, the way they think there is like a hacker would think. You don't think about the consequences of stuff. You think, what's the quickest way I can hack and get something done, without thinking about what the consequences of that may be. So there's a question here, and I don't know anything about Facebook management, but there's a question here about, well, Facebook could probably be a good $250 million company or a multi-billion-dollar evil corporation, and I think we know where they have chosen in that balance. But Cultural movements are reflections about things and not projections. And so let's talk about some of these cultural perspectives on things. Balance sheet accounting did not always exist. This was invented in the early 20th century when stock markets were invented because there was no way to assign a single number value to a company. So they said, well, what if we just subtract the net and the gross and we'll call that, okay, that's balance sheet accounting, that's the value of companies. But then in the postmodern era, people tried to hack that. That's when all these hacks of the financial system, we're still seeing that now in cryptocurrency. I recently recorded a podcast with our corporate lawyer who referred to cryptocurrency as a Russian nesting doll of financial crimes. That is basically his assessment of cryptocurrency. But the meta-modern perspective on this is what we call a humane corporation that doesn't just look at the balance sheet, because if you maximize profit, you end up like Facebook. But you should instead create a balanced, holistic view of the world that you're living in. ThoughtWorks, the company I live for, has done this for a long time. We have to have money. In fact, we view profit as oxygen. If you don't have enough, you're in trouble. But if you have more than you need, it gets dangerous because it's explosive. And so we find a way to spread that around for nonprofit work and pro bono work and things like that. It's a much more holistic view of the world that we're living in. And what that really brings us around to is this idea of ethics, because holism doesn't just impact our decisions in software architecture, it affects the broader decisions we make in the ecosystem that we live in. Remember, we are all connected to everybody else in a really, really intense way. And what you don't want to do is write some software that you later regret and end up going on a decades-long apology tour like the gentleman at YouTube who weaponized their algorithm. This is one of the people who realized that, okay, all of these sites, you know this meme that how much do you pay for Facebook? Nothing. That means you are their product, and they can do whatever they want to you. That's exactly what YouTube did when they did all this user research to try to figure out how can we keep people on YouTube the longest so we can show them more ads. Oh, it turns out people who are angry and fearful will stay around the longest. That's what we're going to maximize. And he's now been on a 10-year apology tour trying to make up for having created that. And we're starting to see pushback inside companies. Google has started saying that we're not going to work on some of the things that China would like us to work for. We're starting to see ethics brought up in some of the press in Silicon Valley. But at the end of the day, the people responsible for not building bad things from a software standpoint, it's you. It's the people who actually build software. Now, you may say, hey, I just built a bomb casing. I didn't know what they were going to put in it. They were going to drop on people. But at some point, you realize the thing you're building is going to be used for something that you might not condone as a person, and you have to start thinking about, do I want to actually help build this or not? Is my paycheck more important than feeling bad for the rest of my life because I accidentally created something that was used for really, really bad things? Remember what Frances Haugen showed us about Facebook. There's a great website that I don't know anything about, but it has a great message that I'm going to end with. And it says, to those who have a choice, refuse to work on systems that profit from digital addictions, refuse to work on systems that centralize control of media in a bad way, refuse to work on systems that prop up an unjust status quo, refuse to work on systems that require unsustainable trade-offs. I'm looking right at you, Bitcoin and cryptocurrencies. And when I talk about that, refuse to work on systems that weaponize the fabric of society, and above all, refuse to work on systems that understand and manipulate people, but offer no affordance for their subjects to understand and manipulate them. Work on something that matters, if only to you. Work on something that helps people, even in small ways. Work on making things understandable. Once upon a time, software let a lucky few of us escape to virtual worlds, choose our own communities, and explore alternate realities. These days, for better or for worse, software defines everyone's reality. Together, let's build one that's worth living in. Thank you very much for having me. Hope you enjoyed it. Thank you.